Welcome to your tutorial on matrices. Matrices, guys, is a pretty fun chapter to deal with, and it's got a lot of facts to it, and also a lot of conceptual portions to it. So overall, it's an easy chapter, but people do find it tough, in certain aspects. So all of it is basically concept. So if you really know your concepts well, then there's no one stopping you from scoring full marks in the matrices section of the examination. So guys, I'm just going to be telling you some certain basics about matrices, and then I'm going to move on to operations on matrices like scalar multiplication and multiplication and addition of matrices that comes before the multiplication part, and also about the types of matrices. Now I messed up my sequence, but I promise you I won't do that when I'm teaching you that. Alright, so let's start with the first most basic thing as to what basically is a matrix. Now, guys, alright, a matrix, guys, is an ordered set. So I'm just gonna write the keywords. It's an ordered set of elements. Now, by elements, I'm not referring to the periodic table here, guys, or entries. That's a better word. So it's pretty much like sets. I'm pretty sure you guys in ICSE have done sets first in class 6 or 7 or 8, I don't remember, long back. But still, it's pretty much a similar thing, except that we've got these brackets right next to the elements. So in case you've already seen certain types of weird numbers like 1, 3, 9, 10, the numbers aren't weird, but the way they're written is weird if you're doing this matrices chapter for the first time. So guys, this is nothing but a matrix. So numbers or elements or entries, you may call it anything, guys, and this is nothing but a matrix. So I may have not numbers but even alphabets or functions like sine theta, or I may have log x, and I may have something to the power of 2 or 9 or anything squared. Now this again is a matrix, guys. So anything written in an ordered set, which is this, is known as a matrix, guys. So that being said, I'm gonna move on to order of a matrix. So I'm just gonna take a different color here. Let's take green, and I'm going to take out this portion of the ordered part, which is order. Now I'm going to talk about order of a matrix. Now if I have a matrix 6, 9, 5, 3, right, and the colors don't matter, please don't get confused. And I say that I'm asked a question as to what is the order of this matrix, guys. Now order basically means the number of rows multiplied by the number of columns. Although you do not perform the multiplication, I'm going to tell you. I'm pretty sure all of you know what a row means. This, guys, is a row, and this here is a column. Right? I'm going to write R and C. So R is column, R is row. I'm really sorry, and C is column. So, guys, this is the first row, this is the second row, this is the first column, and this is the second column. So how many rows do you think this matrix has? If you're saying that this matrix has 2 rows, then it's absolutely correct. This matrix does have 2 rows. How many columns do you think does this matrix have? Correct. This matrix does have 2 columns. So guys, that's what the order of a matrix means. Now this right here is a notation for writing the order of a matrix. Okay, you always write the number of rows first, and then you move on to the number of columns. So in case you know what what the order of the matrix means, which is number of rows and the number of columns separated by a cross. Guys, always never forget to write the row first and then the column. If you mix it up, you will go wrong, because R must come first and then will C come. So R denotes the number of rows and C denotes the number of columns separated by a cross. Will this entire thing give you the order of the matrix, guys? So this is what the order of the matrix means. I'm going to move on to individual elements now, right? So let's look at this element 6 now. If I want to represent this matrix in another form with a variable a, so guys, you always write the row first in any notation in a matrix, in the matrix chapter. So this 6 will have a notation of a1 1. Similarly, this 9 will have a notation, of a1 2. 5 would be a2 1, and 3 would be a2 2. In case you're wondering what this A business means, this is nothing but just A is a variable, guys. Don't get confused. This one, the first one, represents the number of the row of which the first element is a part of. So the first element lies in the first row, guys. So it's the first R is 1. Similarly, when I come onto the column, guys, it is in the first column, and so I write 1 as a C. Now moving on to this, only the column difference is observed, and my column is number 2, the second column, and the row is the same. Here, both the column and the row change. The column does not change, guys. That's this case. The column does not change. Column still remains as the first column, and row is changed to the second row. This one differentiates, this one differs from this element in the sense that the column is the same, guys. However, the row, this is in the second row and this is in the first row, so the row differs. So guys, one thing to be remembered is when you're representing elements and you have notations for them, this A could be anything to A to Z, anything. And when you're writing 1 1, you do not separate them with a cross, guys. That's only the case with the order. So this 2 into 2 is this order. Similarly, when this is 2 into 2 order, you could have any order, guys. For instance, if it is 6 9 5 4 A B C D, there are in all 8 elements, and the order of this matrix is 2 into 4. Now guys, another 2 things to be remembered is you never perform, if someone writes not 2 into 2, I'm just gonna tell you why we do not say it as 2 into 2, but these 2 things are interlinked. Someone who writes 4 here will get a big 0, because this 2 cross 2 here does not mean 4. And please, I'm saying it as cross for a reason. Do not understand or mistake it as an into, guys. In fact, guys, the order of a matrix, for instance, if I want to read out, and if I want to tell my teacher, ma'am, A B C D arranged this way, in this form, would be a matrix of order 2 by 2, not even cross. So I know this is kind of funny that you have an into sign, but you say the by sign, you say the by word, which indicates the division sign. So guys, please don't confuse yourselves. This cross has no meaning. This only represents the order, and you always call it as 2 by 2, 2 by 3, 6 by 2, anything, whatever order. Like for instance here, this will be called as 2 by 4. So from now on, in the tutorials that will follow on matrices, I will be referring to order as 2 by 2. It will be good if you do adopt this habit. And now that you're clear with the order of a matrix, we're ready to move on to equality of matrices and types of matrices. So guys, I'm just gonna take a couple of examples. Let me get this. Okay. By the way, this part is ready. So now let's move on to equality of matrices. The mouse is a little messed up right now, so guys, please just make an effort to understand. Yeah. So we're talking about equality of matrices here. So guys, if I have two matrices like 1, 9, 6. Alright, the 3 should come first, and it's going to be read as 1, 9, 3, 6. And what is the order? It is 2 into 2. 2 by 2, I'm sorry. And I have another one whose order, guys, is again 2 by 2. So it's going to have 4 elements, 2 in each row. So guys, there will be 6, 4, 3, and let it be 4, 8, 7, and 2. Now guys, its order again is 2 by 2, as I told you just now, and these two matrices, although have just 4 elements and they look alike, however their elements are not the same. And not the same meaning that I know that this matrix has 4 elements, which are 1, 9, 3, and 6. And this matrix has elements 4, 8, 7, 2. Now none of them are matching, but this does not mean that the corresponding elements are equal, guys. So what I'm trying to say here is that 1 does not correspond to 4, 9 does not correspond to 8, 3 does not correspond to 7, and 6 does not correspond to 2. Alright, and also guys, if I had a 6 here, right, its order would still be 2 into 2 by 2. However, it again would not be an equal matrix. So if I have A equals this and B equals this, then A, guys, is not equal to B. Also, if you want, I could make this a little more clearer, in the sense that, let me take a bigger size. I know this is a little confusing in the first go, but just try and understand this. Even if I have the same elements, guys, and by the same elements I mean 1, 3, 9, and 6, arranged in a different order, like 6, 3, 9, and 1. Now guys, even this is not an equal matrix. So A still does not equal B. Although the order is same, the elements, the corresponding elements, now here the corresponding elements are not equal, and even if one corresponding element was equal and the other 3 were unequal, we would still call it A not equal to B. Now let me give you the condition when A will equal B. It's pretty easy thing to guess. So now B, if has to equal A, if at all B has to equal A, then all the corresponding elements, like this is A11 as I taught you, so here too this is A11, and A11 here is 1, again A11 here is 1. So if and only if, guys, the corresponding elements are equal, that is, in the second case I have 9, this is A12, and this is A21, which is 3, and A22 is 6. So here, guys, A11 is 1, A11 is 1, here too A11 is 1, here A12 is 9, here 2 again, guys, A12 is 9. Similarly 3 and 6, which are A21 and A22 respectively, are again similar. So if all the places in an element in a matrix equal all the same places in another matrix, and the order of the matrix 1 is equal to the order of the matrix 2, that means number of rows of A equal number of rows of B, number of columns of A equal number of columns of B, we call A equal to B, right? So if I had another column here, guys, for instance, if I had again, if I had 1 and 9, okay, so this matrix does not have another column. So what happens happens is that this 2 becomes a 3. You see, because this is R by C. So the number of columns have now increased one more. So increased by 1, so it's become 3. So guys, the order of the matrices is no longer the same, and thus we call these two matrices to be unequal. So that's pretty much it about equality of matrices. There are two conditions: that A, the corresponding elements are equal. That's the first condition. And actually, the first condition, this is the second. This is the second condition. I'm really sorry, guys. I'm not a professional teacher. I really didn't know how to plan this, and it's really late at night. So please, I'm really sorry, but I'm pretty sure you've done this before. So the first one, the first condition, which is the primary condition, I'm gonna mark. This is condition 1, and this is condition 2. So condition 1 is, guys, the order of the matrices. First thing you do is check if the elements, the order of the matrices is the same. So the elements lie at similar places, guys. Okay. Second thing check is that if at all the order of the matrices is equal, then are the corresponding elements, like are the elements at every place corresponding to the elements of the second matrix. Now guys, I think both these conditions, you've understood them very well. So let me now rush through again, and do I have time? No, I think I'll have to make another tutorial on this. So thanks guys, keep watching.